Yeah, that was confirming what is the new thing.
We're going to send it.
Send it. That's it. Go down. Go
You just see
get it. One person has joined. The get it again.
who should it to me? For my phone, man.
Get it.
Get
Yes, from inside. The last start.
Okay. Okay. Yeah. Yeah. In today's class, we continue from where we stop. We are going to continue from covalent bond. Covalent bond. And I will be happy if you people can listen carefully. If you people can listen carefully. Okay. Okay. Class, let us continue now. We've started with covalent bond, and I told you covalent bond involves sharing of what? Electrons. Sharing of electrons. And covalent bond occur when non-metals combine with what? Non-metals. That's what I said. When you have non-metal combining with non-metal, that is covalent bond. Covalent bond. Today, and before I told you covalent bond occur in what? Molecules of gases, such as chlorine gas, oxygen gas, nitrogen gas, hydrogen gas. Covalent bond occur in all these molecules of gases. And let us look at molecules, compound that exhibit covalent bond. Let's look at molecules of what? Compound that exhibit covalent bond. Number one, formation of water. When you have a molecules of water, when you have one molecules of water, in one molecules of water, the bond that occurred in it is what? Covalent bond. But when you have three molecules of water, it's hydrogen bond. Take note. The bond that occurs within one molecules of water is covalent bond. Just let us stay with covalent bond. We are still coming to hydrogen bond. The bond that occurs in one molecules of water is what? Covalent bond. Take note, the bond that occurs in one molecules of water is what? Covalent bond. In one molecule, within one molecule of water is covalent bond. That means, I told you covalent bond is formed when you have non-metal combining with what? Non-metal. Then when you have H, hydrogen molecule, hydrogen gas, plus O2, oxygen gas, to give you what? H2O, water. Balance the equation. If I put 2 here, I put 2 here. Can you see? Non-metal combining with non-metal to form H2O. In one molecules of water, the bond that occurs in it is what? Covalent bond. Let me draw the structure because I need the structure. I will use the structure to explain so many things. Take note of this. This one is 2 atoms of hydrogen. That means when you have hydrogen coming together, that means when you have hydrogen plus hydrogen gas to give you H2. And don't forget, what is atomic number of hydrogen? 1. He has 1 electron. Plus hydrogen, 1. Both of them come together to share electron. They both come together to share electron. This is what? Hydrogen gas, H2. When you have oxygen plus oxygen to give you O2. That means oxygen is 8. Atomic number of oxygen is 8. That means electron number is also what? 8. You have 2 and what? 6. Isn't it? 6. Class, take note. This one is standing alone, Abi. When you have one electron standing alone, it's known as what? Unpaired electron. It's known as what? Unpaired electron. It's known as unpaired electron. Note this thing. Right. Unpaired electron. Write it down. Unpaired electron. Write it down. Unpaired electron are used in the formation of covalent bond. Take note. Unpaired electron are used in the formation of what? Covalent bond. Unpaired electron are used in formation of what? Covalent bond. But don't forget this. Generally, I told you, valence electron undergo bonding. Valence electron undergo what? Bonding. Please take note of that statement too. Valence electron undergo bonding. Valence electron undergo chemical bonding. What? I will explain. I've explained before, but you were not here. Valence electron undergo chemical bonding. What is valence electron? Take note, class. Take note. What is valence electron? Valence electron means outermost what? Electron. Means what? Outermost what? Electron. The electron on the outermost shell. That is valence electron. Look at this. What are the outermost shell? These are the outermost shell. How many valence electrons do we have here? 6. Valence electron undergo chemical bonding, but unpaired electron undergo covalent what? Bond. Can you see the unpaired electron is still among the what? Valence electron. Isn't it? The unpaired electron is among the what? Valence electron. Valence electron undergo chemical what? Bonding. Unpaired electron, that is when you have just one electron standing. Unpaired electron is one that undergo what? Covalent what? Bonding. Covalent bond. Do you understand? Do you understand? Please, let's move. This is chemistry has never been taught. Okay, let's move now. Please, those who are online, please, I want you to follow. Please, I want you to follow. I want you to follow. Plus, look at this. Another oxygen. You have 2, 6, and 6 on the outermost shell. Then what happened? This unpaired come. Have you? We combine. I'm coming. Okay. Okay. 1, 2, 3, 4. Okay. Yeah. 2 unpaired. Then from here, what do we have? This, this one will come together. Come together. You have this. This one, this. These are those one. This. You have it like this. Then this unpaired. 1, 2. This unpaired. 1, 2. This is what? Oxygen gas, isn't it? Then look at this reaction. And now carry this thing. This one, this is hydrogen gas. Yes. Isn't it? Hydrogen gas. Isn't it? How many of the hydrogen gas do I have? 2. Isn't it? Plus oxygen gas. This is oxygen gas, isn't it? Plus oxygen gas. That means 2. This 2 means what? This 2 inside, 4 electron. This one, that is this 2. You understand? Instead of writing, then the 2, this one, this 2. Then you have 1, 2. Then what happened? There's formation of water, isn't it? Formation of water. Formation of water. Let me draw it here. Class, look at this. How many hydrogen attached to oxygen? How many hydrogen? 2 in 1 molecules of water. How many in 1 molecules of water? How many hydrogen do you have that are attached to oxygen? 2 hydrogen attached to what? Oxygen. Yeah, the oxygen is the central what? Atom. The oxygen is the central atom. That means now this oxygen, they separate. If they separate, they form back this. This oxygen, they will separate. They will form back this. That means you are. This is 2. This is 1. This is this. That means then we have how many hydrogen attached to it? 2. That means these 2 hydrogen, they will also separate back to this. They will also separate back to this. And know that for this hydrogen to be stable, it must have how many electrons on the outermost shell? 2. Because it only has 1 shell, which is K shell. And K shell can take how many electrons? 2 electrons. This hydrogen, get back to this. We now come here, attach itself to this place. This second hydrogen too will come here, attach itself to this. This is the structure of what? H2O. Can you see it? For oxygen, this is the oxygen, which is the central atom. How many hydrogen, how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. For this hydrogen, how many electrons do we have? 1, 2, stable. For this hydrogen, how many electrons do we have? 1, 2. But how many molecules of water do we have? 2. That is, if I want to, the second oxygen, this is 1 oxygen, the second oxygen, these other 2 what? 2 atoms of what? These 2 what? Atoms of what? Hydrogen. Do you understand?
Yes.
Do you understand? That is the structure of covalent bond of water is what? This. Do you understand?
Yes.
Do you understand?
Yes.
Oh, those people online, you understood? Please, if you understand, comment I on the group so that I can know. If you understand, please.
Say yes.
Huh?
You say yes.
Please say yes. Okay? You understand? You understand? Say yes. Please, I'm waiting for you on the group. Say yes. Please. Please say yes. Because I want to bring out something here. You need it. What I want to bring out, you need it. This is the water. Okay, thank you. Thank you. This is the water. Then the second, oxygen. These two, we are attached to it. Take note. Class now. Now listen. Please, everybody listen. Everybody listen. Look at this water. What bond? I told you, covalent bond occur within one molecules of what? Water. It's a bond that occurs within one molecules of what? Water. Look at this water. You know that these two electrons are shared, Abby. These two electrons are shared between hydrogen and what? Oxygen. When you have two electrons being shared, it is known as what? Shared what? Pair electron. If I say a shared pair electron means how many electrons? Two. And this shared pair electron is called what? Bond pair electron. It's also called what? Bond pair electron. A bond pair electron means how many electrons? Two. That is shared. That means these two electrons, they are called what? Shared paired what? Electron. Or a bond pair what? Electron. That means in water, in this water, how many shared paired electrons do we have? Shared pair. I didn't say how many shared electrons. Shared paired electron. This is a shared pair electron. This is another shared pair electron. How many shared paired electrons do we have? Two. But how many electrons are shared in water molecule? Four. You understand? Between oxygen and two hydrogen. But how many shared paired electrons do we have? Two. This is a shared pair. This is another one, shared pair. And a shared pair is known as what? Bond pair. Isn't it? That means this one that is not shared is known as what? Lone what? Lone pair. How many lone pair of electrons do we have in water? How many lone pair? Two. This is one lone pair. This is another what? Lone pair. In water, how many lone pair electrons do we have? Two. How many shared pair? Two. Take note of that. Take note of that. That means when you have oxygen, and take notes. Type. Stop writing. When you have a shared pair, which is bond pair, is represented by what? One line. Do you understand? That means one line means how many electrons? Two. Now one line means what? A shared pair or a bond pair. That means for this water, this is hydrogen. This is what? Hydrogen. Then this lone pair are these. Take note. Take note. Take note. But the molecular structure of water is bent shape of this shape. The reason that there's what? A strong repulsion between the word lone pair, a strong repulsion. It's a bent shape, this shape. When we get there, you understand. When we get there, you understand. Class, if they ask you, in what, how many shared pair? How many lone pair? 2. Take it. Another formation of ammonia. Let's move. Formation of ammonia. Another one. Formation of ammonia. 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 Of ammonia. Formation of ammonia. In ammonia, when you have nitrogen gas plus hydrogen gas to give you ammonia gas. Balance equation, put 2 here, put 3 here. Listen, class. Without doing much, I've given you the structure of nitrogen before, have you? Let me quickly explain. Once you understand ammonia, we just go to other things. Look at this, please, class. Nitrogen plus nitrogen to give nitrogen gas. Atomic number of nitrogen is what? 7. That means if you draw the structure 2, you have 5. Abi? How many ampere do we have? 3 plus 2. 5, Abi? You have to fill singly in 4 places before you appear. How many ampere do we have?
3.
What we undergo the bonding, the ampere. I told you ampere undergo what? Covalent what? Bond. Ampere electron. That means the ampere. That's why they say nitrogen form how many bond? Triple covalent bond. Oxygen form how many bond? Double covalent bond because it has 2 ampere. Nitrogen has 3 ampere. It forms triple covalent bond. Oxygen has 2 ampere. Double covalent bond. Chlorine has 1 ampere. Chlorine has 1 ampere. It forms single covalent bond. Hydrogen has 1 ampere. It forms what? Single covalent bond in nitrogen gas. Nitrogen gas is what? Triple covalent bond. That means we have this. Then these 3 ampere come here 1, 2, 3. These 3 ampere too. 1, 2, 3. That means if you draw the structure, this is nitrogen. These 2, 1, 2. These 2, 1, 2. I told you 2 electrons means 1 word, shared pair, that be 1 line. That means 1. Another 2 electrons means another line. Another 2 electrons means another line. That means how many electrons for this one? 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen form what? 3 covalent bond. But that is not what I'm explaining now. Then you have hydrogen. I've given you the structure of hydrogen now. Then what happened? This nitrogen gas split back to this. That means let's take one of it. You have 2 and you have what? 5. Abi? Then how many hydrogen attached to it? 3. That means hydrogen is like this, Abi. 1 atom of hydrogen. That means they will come here, attach. Another hydrogen, attach. Another hydrogen, attach. Can you see? In ammonia, how many shared paired electrons do we have?
You have 3.
How many lone pair? How many bond pair? Bond pair electron. Bond pair means what? Shared pair. They are still 3. Bond pair means shared pair 3. How many lone pair? 1. Write it down. Please, hope those people online are following us. Please, hope those people online are following. Please, hope those people online are following. Hope those people online are following. Hope those people online are following us. Hope those people online are following. Hey, please take note of this. Please take note of it. Class, if I write in phosphine, look at this. Without doing anything, how many shared pairs will be there? How many like this one? That means we have P, H, How many shared pairs? 1, 2, 3. How many lone pairs? 1. Ammonia, if I draw it, Lewis structure. This structure is called Lewis structure. It's a topic I will teach you when we get to that place. Please tell your friend when you resume, especially the SS3 student, for you to have 300 plus in JAM, 3 subjects, physics, chemistry, math, just 50,000 naira for the whole term, just 50. You will get top notch of physics, top notch of chemistry by me, physics, chemistry, then top notch of mathematics from Mr. Odola, just 50. For you, we are going to start from the beginning of WAEC and what JAM scheme of work, and you will see topic has never been before. Then before you move to your JAM, we are through with it. We solve a lot of past questions, a lot of questions. It's just 50,000 naira, and we are looking for 100 students. We are 100 students, and those 100 students, if you are not serious, we send you back, because we want to produce 300 plus. It will be the first time that Queen's College will produce 300 plus, like 100 students, and we break record. We want to have a student with 380, breaking of record, setting of record in JAM, 380. In your chemistry, you can have 98 over 100. In your physics, 98 over 100. There's a way you can do it without no stress. Without no stress. Okay, let's move. Let's move. Let's move. Okay, look at this. 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 Let me give another one. Formation of methane. 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 What's wrong with you? About that. Let's see. I want to sleep. Don't sleep. Just fall on this. Formation of methane. Formation of methane. When you have C plus H2 to give you CH4, balance the equation, put 2 here. Class, which one is the central atom? Carbon. Carbon. I told you hydrogen and what? Fluorine can never be a central atom. Hydrogen and fluorine can never be a central atom. Take note. Hydrogen and fluorine can never be a central atom. Why? Why? Because hydrogen has one shell. One shell. One shell. For fluorine, because of the size and electronegativity of fluorine, because of the size and electronegativity of fluorine, they can never be what? A central atom. Take note. They can only be a corner atom. Corner atom. Okay, listen now. You have this. That means without doing anything, if you see this CH4, how many lone pairs in methane? Lone pair. Lone pair. Lone pair. How many lone pair will be in methane? That means you have CH. How many lone pair? Do you have any lone pair here? None. No lone pair in methane. How many shared pair? 4. All the electron has been shared. 0 lone pair. Look at this girl. Okay, this is it. That means, what is carbon? Carbon is what? Atomic number 6, Abi? Yes. That means you have 2 and you have what? 4. Isn't it? Abi? Yes. Then how many hydrogen attached to it? 4. One hydrogen come here with its own electron. Another hydrogen here with its own electron. Another hydrogen here with another hydrogen here. Can you see it? That means all the electrons. That means together now, how many electrons on the atomic shell of carbon? 1, 2, 3, 4, 5, 6, 7, 8. Now balance. Okay. Do you understand? Yeah. Do you understand? Yes. Take note of that. Take note of that. Right. Types of covalent bonds. Types of covalent bonds. Types of covalent bonds. Types of covalent bonds. Please, I want you to listen. I want you to listen, please. I want every one of you to listen, please. This is very important. Very, very important. Very, very important. Very, 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 very important. Very, 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 very important. Using Pauling scale value. Pauling scale value. Pauling scale value. Pauling scale value is called electronegativity difference. Pauling scale value. Don't bother yourself with the name. But when you get to 100 level, you have to know the name. Pauling scale value. That is electronegativity difference. Types of covalent bond. We have 1 non-polar covalent bond, covalent compound, and we have polar covalent compound. Non-polar and what? Polar. Non-polar and what? Polar. Non-polar and what? Polar. We have non-polar and what? Polar. Non-polar and what? Polar. Take the first one. Non-polar. Non-polar. Covalent compound or covalent bond. Then non-polar covalent bond. Right. This bond occur. This bond occur. This bond occur between atoms, between atoms, between atoms, between atoms that share electron equally. Electron what? Equally. Between atoms sharing electron equally. We are talking about covalent bond. Someone asked, we are talking about covalent bond. Covalent bond, all the examples I've done in water. Covalent bond occur in 1 molecules of water. Covalent bond occur in 1 molecules of ammonia. Covalent bond occur in methane. We are talking about covalent bond, covalent bond, covalent bond. We are talking about covalent bond, not hydrogen bond. We haven't gotten to hydrogen bond. Water can exhibit hydrogen bond, but there must be condition with that. When can water exhibit hydrogen bond? When you have 3 molecules of water, the 3 molecules of water, when you have 3 molecules of water, the bond among 3 molecules of water is what? Hydrogen bond. But when you have one molecules of water, in that one molecules of water is covalent bond. In one molecules of water is what? Covalent bond. Take note. I told you, example of what? Intermolecular bond is hydrogen bond. And what is intermolecular bond? When I gave you intermolecular bond, I said this is a bond that occurs between separate what? Molecules. Between separate what? Molecules. When you have intermolecular force, thank you. Intermolecular force. Hydrogen bond is an example of intermolecular force. This is the force of attraction that occurs between what? Separate what? Molecules. When you have one molecules of water, another one molecules of water, another one molecules of water, the bond that now occurs between that one molecules of water and another one molecules of water is what? Hydrogen bond. When I have another one molecules of water, the bond that occurs between those one molecules of water is what? Hydrogen bond. But when you have just one molecules of water, one molecules of water is what? Covalent bond. But when you have one molecules of water, another one molecules of water, another one molecules of water, the bond that occurs between that one molecules of water and this one molecules of water and this one molecules of water is hydrogen bond. Do you understand? Do you understand? Do you understand? But when you have just one molecules of water, the bond that occurs in it is what? Covalent bond. But when you have one molecules of water here, another one molecules of water here, another one molecules of water there, the bond that occurs between that one molecules and this one molecule and that one molecules is what? Hydrogen bond. Do you understand? Take note. Take note. It's not your fault the way they explain them to you. That's the reason. Don't worry. We are getting there. We are getting there. Okay. I said we are types of what? Covalent. We are non-polar and what? Polar. What do I say about non-polar?
It's what I call share atoms that share electron.
That this bond occurs between atoms that share electron what? Equally. Or have electronegativity value. Have electronegativity value to be almost the same. Or have electronegativity value. Or have electronegativity value to be almost what? The same. Or have electronegativity value to be almost what? The same. Or have electronegativity value to be almost what? The same. Please listen to this. Right, note. It occurs in atoms that are the same, open a bracket, identical atoms. It occurs in atoms that are the same, identical atoms. It occurs in atoms that are what? The same, identical atoms. It occurs in atoms that are the same, identical atom. Please just they follow me. Please, they follow me. For this non-polar covalent bond to occur, electronegativity difference. This is what? When you see S, is what? Electronegativity. Then when you see delta, is what? Change. Which is what? Difference. Electronegativity difference must be less than 0.5. Write it down. When you have electronegativity difference,
What about that 1.9?
I'm coming. When you have electronegativity difference to be less than 0.5, the bond you will have in that molecule is what? Non-polar covalent bond. When you have electronegativity difference to be less than 0.5, that means it could be 0, it could be 0.1, it could be 0.2, it could be 0.3, it could be 0.4. When you have electronegativity difference to be what? Less than 0.5, the kind of what? Bond we have is what? Non-covalent bond. Let's look at this, for example. Let's look at this, for example. Let's look at this. Let's look at this. Hydrogen. Electronegativity value for hydrogen is what? 2.1. Electronegativity value for hydrogen is what? 2.1. You now have hydrogen gas. Identical atom, Abi. I told you in an identical atom, what kind of bond you have? Non-polar. This is hydrogen gas. What is electronegativity value for hydrogen? 2.1. Therefore, electronegativity difference is what? 2.1. The first hydrogen, Abi, minus the second hydrogen. What do we have? 0. You understand? It is what? Non-polar. Non-polar. That means in this molecule, what will be the covalent bond? Polar or non-polar? Once they are the same, I told you, since they are identical, it's what? Non-polar. When you have identical atoms, it will be what? Non-polar. If you have oxygen gas, what will be the covalent bond? Polar or non-polar? Non-polar. That means the electronegativity value of one oxygen minus the electronegativity value of the second oxygen will give you what? 0. Isn't it?
Yeah.
Isn't it? For example, what is electronegativity value? Look at this. Electronegativity value for oxygen is 2.5. Is 2.5. Therefore, you have electronegativity difference of O2 be what? 2.5 minus what? 2.5, which is what? 0. When you have identical atoms forming a molecules of gas, the bond will be what? Non-polar covalent what? Bond. Another example. What is methane? Is it polar or non-polar? I will give you the electronegativity value. You don't need to know it offhand. For carbon, the electronegativity value for carbon is what? I'm sorry. Oxygen is 3.5. For oxygen is 3.5. That is 3.5 minus what? 3.5. You don't need to know it offhand. They won't ask you to know the electronegativity value for element offhand. They won't ask you that. Therefore, electronegativity value for carbon is what? 2.5. Electronegativity value for hydrogen is 2.1. What is electronegativity difference now? For methane. Electronegativity difference from methane will be what? 2.5, Abi? 2.5 minus what? 2.1. You have what? 0.4. Is 0.4? And I told you, when you have electronegativity value less than 0.5, what bond?
Non-polar.
That means in methane, what bond?
Non-polar.
Methane is non-polar covalent bond. Are you following?
Yes.
Non-polar covalent bond. Please, if you are following online, please say yes. 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 Thank you. Someone said yes. Thank you. Thank you. Thank you. Thank you. Please say yes. Thank you. Thank you. Thank you. Please say yes. Thank you. 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 Okay, let's go to polar covalent now. Polar covalent. Polar. This occurs, polar covalent bond now. This occurs when electrons are shared unequally. When electrons are shared unequally. In this one, in non-polar, they share it equally, Abi. Why? Because their electronegativity difference are almost what? The same, Abi. But for polar, the electrons are shared on what? Equally. The electrons are shared on equally, unequally. The electrons are shared unequally. Therefore, creating a partial charges. This is partial charges. Therefore, creating a partial charges. Therefore, creating a partial what? Charges. Therefore, creating a partial what? Charges. Therefore, creating a partial charges. This is due to, listen, this is due to the higher electronegativity atoms. This is due to the higher electronegativity atoms. This is due to the higher electronegativity atom. This is due to the higher electronegativity atom pulling the electron towards itself. Pulling the electron towards itself. Pulling the electron. You want to have all the electron. It's just like I want to share something with one of you students now. Because I'm stronger than you, what will I do? I want to, instead of us to share it equally, because I'm stronger than you, I want to pull it towards my what? Self. Now means when you have two atoms coming together to form a covalent bond, two non-metals and non-metals coming together to form what? Covalent bond. Instead of them to share the covalent bond, to share electron rather, when you have two atoms come together to form a covalent bond, two atoms, non-metal, come together to share bond, to form what? Covalent bond. Instead of them sharing electron equally, but the stronger one want to take all the electron, it will result into what? Not sharing the electron what? Equally. The electron will now be shared what? Unequally. You understand? Do you understand? The electron will be shared unequally. Why? Because the stronger one want to take all the electron. Which one is the stronger one? The one that is highly what? Electronegative. What is the meaning of electronegativity? The love for electron. Ability to what? Accept electron. Ability to accept electron. Because I have higher ability to accept electron, I want to take all the electron. Do you understand? Do you understand? Right. Someone send message. Let me read. Sir, can you repeat the meaning of polar covalent? I said polar covalent occur. Class, it occurs when? When electrons are shared unequally. Electrons are shared unequally. Therefore, creating partial charges. Why? The higher electronegativity element, want to have all the electron towards itself. Two non-metals coming together to share electron. Instead of them to share the electron equally, but because this one is more electronegative, You want to pull all the electron towards itself. That means there will be result. This one will now result into what? Unequal sharing of the electron. Will be resulted into unequal sharing of the electron. Why? Because the one that is more electronegative want to pull all the electron towards itself, and it will result to unequal sharing of what? Electron. That means in polar there is unequal share of what? Electron. Why? Because element that is highly electronegative want to pull the electron towards itself. Take note of that. You will understand better when you have this example now. If you have this example, 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 if you have this example. I have so many examples which I will use their electronegativity value. Class, listen. Take note of it. When you have electronegativity difference, take note, between 0.4 and 1.8. That means when you have electronegativity difference to be greater than what? 0.4, less than what? 1.8. When electronegativity difference is between 0.4 to 1.8, the kind of bond that will be formed is what? Polar, would be what? Polar covalent what? Would be what? Polar covalent bond. Write it down. Polar covalent bond. I will give you an example. When you have electronegativity difference is known as what? Pauling scale value. Pauling scale value. Pauling scale value. Don't bother yourself with that. Electronegativity difference. When you have electronegativity difference between 0.4 and 1.8, when electronegativity difference is greater than 0.4, less than 1.8, the bond that will be formed between those two non-metal will be a polar covalent bond. That means electron will be shared unequally. Example, look at water. Water is what? Polar. That's why they say water is what? Polar or solvent. If they ask you, give an example of polar solvent, what will you say? Water. Why? Because water is what? Exhibit what? Polar covalent bond. That's why they say water is a polar solvent. It has partial positive charge and partial what? Negative charge. It's a polar solvent. Polar. Let us see. What is electronegativity value for hydrogen? Electronegativity value for hydrogen is 2.1. Electronegativity value for oxygen is what? 3.5. Then let's look at the difference. 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 The formula, electronegativity difference equal to what? 3.5 minus 2.1. What do we have? 1.4. Is it between these? Is it between these? Therefore, it is what? Polar covalent. Are you following me?
Yes.
Please follow. Casa. Please follow. Follow. Someone send message. Okay, not me. Okay, look at this. Is HCl polar or non-polar? Do it yourself. Electronegativity value for hydrogen is what? 2.1. Electronegativity value for chlorine is what? 3.0. Is it polar or non-polar? Do it yourself. Is it polar or non-polar? Please drop your answer in the comment. HCl, is it polar or non-polar? It's what? Polar. It's polar. Someone said, in electronegativity difference, must the bigger one always subtract the smaller one? Yes. You take away the smaller one from the bigger one. Yes, that's the principle. You take away the smaller one from the bigger one. Yes. You take away the smaller one from the bigger one. Yes. You take away the smaller one from the bigger one. Yes. ACF, is it polar or not? Take note. Polar. Please take note. Please, polar. Look at this. When you have ammonia. Let's look at ammonia. Nitrogen, the value for nitrogen. The value for nitrogen. Is it polar or non-polar?
Non-polar.
Or non-polar?
Non-polar. Is it non-polar?
Look at ammonia. Is ammonia polar or non-polar? Nitrogen is 2.1. Hydrogen is what? Nitrogen is 2.9. Hydrogen is 2.1. It is what? Class, it is what?
Non-polar.
No, non-polar.
It's polar.
Polar or non-polar?
Sorry, I mean it's polar.
Polar, please, polar. Ammonia is polar. Yes. Then take note, right? Notes. This one came out in JAM last year, 2025. Notes. When electronegativity difference, Pauline's scale value, is greater than 1.8, the bond will be ionic. Another name for ionic is what? Electrovalent. Once is 1.8. Some people will say, some school of thought will say above 1.7. Some school of thought will say above 1.9. Some school of thought, the one that came out in JAM last year was when electronegativity difference is 1.7, is still what the same. Some people say above 1.7, above 1.8, above 1.9. When electronegativity difference is greater than 1.8, some people say 1.9. Some people say 1.7. It is what? Ionic bond. Look at this. For example, when you have sodium, electronegativity value for sodium is 0.9. Electronegativity value for chlorine is 3.0. What is electronegativity difference? Yeah, is it sodium and chlorine when they combine? Is it ionic, polar or non-polar covalent? Is it ionic bond, polar covalent bond or non-polar covalent bond? For sodium chloride now, the higher one is what? 3.0 minus what? 0.9. What we have? 2.1. Can you see electronegativity value is what? Greater than 1.8. Then sodium chloride is what? Ionic. Sodium chloride is ionic. Look at this one. When you have magnesium chloride, value for magnesium is 1.2. The value for fluorine is what? 4.0. What is electronegativity difference? Magnesium fluoride. What is electronegativity difference?
2.8.
What? 2.8. Is it greater than 1.8?
Yes.
That means it is what? Ionic bond. Take note of that. Take note of that. Are we following?
Yeah.
Right. Molecular shape. Molecular shape. molecular shape, molecular shape, molecular shape, molecular shape, molecular shape. Right, molecular shape, molecular shape, molecular shape, molecular shape. Oh yes, molecular shape. VSEPR. Right. Valence shell electron pair repulsion. 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 Right. This is used. Right. This is used to predict methane, the shape of what? Ethene, the shape of ethyne. These are just what they want you to know. What they want you to know. According to then, what we use to predict shape? We have geometry shape and we have molecular shape. Take note. We have geometry shape and molecular shape. In WAEC and JAM, they only want you to know what molecular shape. Only molecular shape of this. You don't need to bother yourself about geometry shape. In JAM, in your scheme of work, they didn't require geometry shape. In WAEC, they didn't require geometry shape. But in A level, you have to know geometry shape and molecular shape. But in JAM and WAEC, they just want you to know what molecular what shape and molecular shape of all this one. You won't go beyond that. That's what they want you to know. And what do we use to know shape, molecular shape and geometry shape? So VSEP what? It predicts. Just let me give you how you can know this. Take note. You people have known the meaning of lone pair. You've known the meaning of what? Shared pair, bond pair. Bond pair determine the molecular what? Shape. Bond pair, write it down. Bond pair determines the molecular shape. Take note. Bond pair determines what? Molecular what? Shape. What did I say? Bond pair determines what? Molecular shape. While lone pair influences it a little bit. 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 Bond pair determines the molecular shape. Lone pair influences it a little bit. That means lone pair has a little bit of influence on it. A little bit of influence on it. Bond pair determines it. But lone pair influences it a little bit. Take note of that. Take note of that. Take note of this. When you have this, when you have a molecule, bond pair, let me write bond pair. Please, let us lone pair. Please, take note of lone pair. Molecular shape, molecular shape. Molecular shape. Write this thing. Write it, please. Write. Wow. Right. Because I have so many examples here. Have you said, please draw that table. Please draw that table. Class, have you said? Listen, class, look at this. When you have one pair to be 4, and you have lone pair to be what? 0 in a molecule, the shape will be what? Tetrahedral. The shape what? Tetrahedral. That's that. When you have one pair to be what?
4.
To be 4. Lone pair to be what? 0. The shape of that molecule you are. The shape of that molecule you are. Look at this. Methane. Methane. How many bond pair do we have?
We have 4.
Bond pair means what? Shared pair. We have shared pair that are shared. Shared pair. How many do we have? 4. How many lone pairs do we have?
0.
Then what is the shape of methane?
Tetrahedral.
That's it. Don't cry it. In phosphonium. What is the shape?
Tetrahedral.
What is the shape?
Tetrahedral.
How do you know? P, H, 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 H. How many shared pair?
4.
That means one pair is 4. One pair is what? Shared pair. How many lone pair? 0. What is the shape? Tetrahedral, molecular shape. In ammonia, what is the shape? Tetrahedral. Do you understand?
Yeah.
Don't cram it. Don't cram. Don't cram. People online, do you understand? Don't cram. Please, if you understand, I'm waiting to say yes on the comment. Please say yes. Please say yes. Please say yes before I move. I must see yes. I must see yes. Let me see yes before I move. Before I move, say yes. Please say yes. I'm waiting for you. Those people online. Please say yes. Please, I'm waiting for you. Molecular shape of ammonium phosphonium. This one is ammonium. NH4. NH4. Ammonium. 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 pH4. Phosphonium. Phosphonium. pH4, their shape is tetrahedral based on this. You don't need to cram. Don't cram. Don't cram. Please don't cram. Please, I'm waiting for your yes. I'm waiting for your yes so that we can. Okay, thank you, thank you. You all understand? I like that. I like that. I like that. May God be with you all. May God be with you. May God be with you. Please, you can't get it anywhere except in neotisa. That's where you can get the real teaching, the real teaching, the real teaching, the real teaching. When you have next one, bond pair to be 3, bond pair to be what? 3, bond pair to be what? 3, and you have lone pair to be 1. Cram it. What will be the molecular shape? Class, I told you we have we have geometry shape. For O level jam, don't bother yourself with geometry shape. When you get to advanced, we are there for you. If you want to, when you get to 100 level, I'm there for you. But for O level, don't bother. Take note. When you have bond pair to be 3, lone pair to be 1, What would be the molecular shape? The molecular shape is what? Trigonal pyramidal. Trigonal pyramidal. What are the examples of these? What are the examples of these? What are the examples of these? Examples of these. Examples of these. Examples of these. We are still going to talk about their bond angle. Jam. We don't play with that also. Bond angle. Example of this, we have ammonia. Let's look at ammonia. In ammonia, this one is ammonium. Take note. This one is ammonium, NH4. Someone send message. Let me confirm if it's from the... Sir, I cannot see the spelling of trigonal. Okay, I'm sorry. Trigonal pyramidal. This is pyramidal. Trigonal pyramidal. Pyra. Pyramidal. Please, okay. I've taken care of that one. Trigonal pyramidal. Thank you. Trigonal pyramidal. Hope you've seen it, you've understood it. Okay. Okay, example of this. Look at this, ammonia. In ammonia, look at this. We have this. In ammonia, how many shape pair do we have? We have 3 bond pair. 1, 2, 3. Bond pair is shape. Ammonium is what? Tetrahedral. Phosphine is what? Phosphonium is what? What about PCl3? Phosphorus trichloride is also an example. Write them down. Trigonal pyramidal. Are we following? Can you see? In chemistry, you don't need to cram. Just know the basic. The basic. You don't need to cram. No, you cram the shape. Shape of this one. And I've forgotten. Once you know the basic, how can I get the number of bonds? Okay, please. There's a simple way to get number of bonds using Lewis structure. That one is another topic. I will teach you when you get it. When you resume Lewis structure. You don't bother. You understand? Lewis structure. Before you go for your exam, I will teach you understand. Before you go, Lewis structure. All these things, they are Lewis structure. There's a way we draw Lewis structure. Are we set? Yeah. When you are bond pair to be 2, lone pair to be 2, the shape is for bent. Right now, bent shape. Write it down. Bent shape. Another name for bent shape. Sometimes you might not see bent shape. You can see V shape. That's shape of water. It's like this. The shape of water is like this. O, that means like this. Bent, V shape. Bent shape. Are we set? Yeah. Are we set? Example of this. H2O, water. H2O. How many in water? Look at it. In water. How many shape pair? How many lone pair? Therefore, it is what? Bent shape or V shape. H2S. hydrogen sulfide. How many shared pair? How many lone pair? Therefore, it is what? N shape. Write it down. Write it down. Write it down. Please, people online, please hope you are following. Please, you have to follow. You have to follow, please. Are we set? Are we set? Next one. Next one. When you are one pair to be 3, lone pair to be 0. One pair to be 3, lone pair to be what? 0. That one is trigonal planar. Trigonal. Now this 3-1 is what? Trigonal pyramidal. 3-0 is what? Trigonal planar. Trigonal planar. Planar. Trigonal planar. Trigonal planar. Trigonal planar. Trigonal planar. Trigonal planar. Trigonal planar. This one in A level we have boron trifluoride, but for O level it's just only one they want you to know, which is what? 18. Example of this one, write it down. 18. That means member of alkene. The shape of alkene is what? Trigonal planar. Trigonal planar. We have so many examples for this in advance. We have SO3, we have boron trifluoride, we have them like that. But for your own level, in O level, it's only one example, which is what? 18. Just 18. Take note. 18. Yes, is 18 and alkene the same? Yes, look at this. I'm sorry, in your studio, please, when you resume, you have to come 3 subjects, 50,000. Organic chemistry is the key in chemistry also. Organic chemistry, I will dissect organic chemistry for you. You will understand. Organic chemistry is the simplest and is the what? Is the hardest. As it is simple, it's also hard. Take note. Alkene is an homologous. It's an what? Homologous. The member of alkene is what? 18. 18 is first member of what? Alkene. He has a general formula of CnH2n. The shape is what? Trigonal planar. The bond angle is for 120 degrees. The hybridization is what? sp2. It is known as for double bond. It is for double bond hydrocarbon. It has sigma bond and pi bond electron. Don't worry. But just need to 18 is what? Member of this homologous series. Member, the first member of alkene. The surname is Ene. That's the surname. First member of this homologous series is what? 18. And the shape is what? Trigonal planar. Why? Because it has 3 bond pair and what? 0 lone pair. 0 lone pair. 0 lone pair. Take note. The central atom has 3 bond pair, 0 lone pair. Take note of that, please, so that we can call it a day. Let's move. Should I rub this one? Let me rub this one off. Then class, listen. Bonus. When you have this one, H2, Cl2, N2, F2, comma, BR2, comma. All these ones, they are linear in shape. They are what? Linear in shape. Linear. When you have these atoms forming molecules of gas, the same atom, they are linear in shape. Linear. Oxygen gas is also included. Linear. All these ones are linear. Then you have CO2. You have ethyne. Ethyne. Ethyne is what? C2H2. This one too, they are also what? Linear. Linear in shape. Linear in what? Shape. Linear in shape. Take note, those are linear in shape. Don't kill yourself. They are what? Linear in shape. Linear in shape. I will explain better. Linear in shape. Linear in shape. This is what Jam wants you to know. Or this one I've given you. That is what Jam wants you to know. Linear in shape. And take note. Take note. Class. How to give you something. Bond angle now. Right. Bond angle. Bond angle. Which will be the last one for today. Bond angle. 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 You have to know their bond angle. Bond angle. Are you following? Are you following? Bond angle. Bond angle. Bond angle. Class, listen. Please listen. Please listen. When you have all these molecules with linear shape, all these molecules with what? Linear shape. When you hear any molecular shape that is linear, 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 their bond angles were 180 degrees. That's that. Linear means what? 180. You understand? Linear line. Angle on a straight line, 180. Any molecule that is what? Linear in shape, their bond angle is what? That is what is the bond angle of what? Ethyne. CO2. Nitrogen gas. Fluorine gas. 180. 180. 180. Degree. 180. Are you following? Is it easy? Look, you are tired. Oh, this is last one. Don't worry. Don't worry. I know that. I'm also tired. When I get home now, I'll go and sleep. Because I didn't sleep yesterday. I was coding. Coding. Throughout. I was working on a project. It's not easy to be sincere. It's not easy to be easy. Okay, let's move now. Right. Let me quickly run this one up. In the next 3 minutes, we'll be through. We'll be through. In the next 3 minutes. We'll be through. We'll be through. What is the shape of ammonia? You say tetrahedral. That is tetra. What is the bond angle? The bond angle is for 109.5 degrees. Take note. The bond angle of when you have tetrahedral molecular shape, their bond angle is for 109.5 degrees. But there's little exception. There are little what? Exception. Little exception there. But at this level, don't bother yourself with the exception. Don't bother you, because if you want to go to the exception, we go to geometric shape, go further. This level, don't kill yourself. Don't kill yourself. Don't kill yourself. Class, ammonia. The shape of ammonia is what? Trigonal what? Pyramidal. The bond angles were 107 degrees. When you see trigonal pyramidal, their bond angle is what? 107. But phosphine is not 107. No. Listen, class. Listen. Phosphine is trigonal pyramidal too, like ammonia. But the exception occur on this one. This one is 93 degrees. But nobody will ask you for that at this level. Just know that when you are trigonal pyramidal, it's what? 107. Example, ammonia. The bond angle of ammonia is what? Is what? 107. 107. 107 degree. 107. 107. 107. When you have H2O, water, which is what? V-shape, Abi, or bent or V-shape. The bond angle is 104.5 degrees. But when you have phosphine, hydrogen sulfide is 92.3 degrees. It's an exception. Hydrogen sulfide is also what? Bent shape. The bond angle is 92. But just take note of only this one. Jam won't go beyond this. Jam will not go beyond this. Do you understand? Hope that you understand everything we've done today. Hope that you understand. By God's grace, next class, next week, I will have to finish chemical bonding, then go to a nice topic, which is periodicity. Then after periodicity, we go toward calculating aspect of chemistry, after which we go to organic chemistry. That's how I want to design it. At this moment, let us call it a day. I see you when you see me. I remain Jama. May God be with you. Amen. Take care. This one.
Listen.
Take care.
Bye-bye, sir.
Take care. Why? You are sick. People online, we are true. You still want to learn? We see you where you see. May God be with you all. Amen. Huh? Yeah, you can join online now. Yeah, why not?